Problem 21. Because the green paint covers 300 square feet, so for each surface it will cover 300 divided 6 equals 50 square feet. And for each surface, the area is 10 square equals 100 square feet. Therefore, the wide area will be 100 subtract 50 equals 50 square feet. The answer is D. Problem 22. Because the set of integers, the number is 9, and 6 of the elements are known, so we assume 3 other elements to be x, y, z. And let's look at 2 extreme cases. The first is if x, y, z are smaller than 2, then the set will be x, y, z, 2, 3, 4, 6, 9, and 14. In this case, the median will be 3. And the other case is if x, y, z are all larger than 14, then the set will be 2, 3, 4, 6, 9, 14, x, y, z. And for this case, the median is 9. Therefore, for other cases, the median will be somewhere between 3 and 9. So the total number of possible values of the median will be 9 subtract 3 plus 1 equals 7. The answer is D. Let's assume the equilateral triangle has side length L, and its perimeter will be 3L. Because the perimeters of the triangle and the hexagon are the same, therefore the side length of the hexagon will be 3L divided 6 equals L over 2. Now the hexagon can be divided into 6 equilateral triangles, with each triangle with side length L over 2. So because the side length of the small equilateral triangle in the hexagon is half of the larger equilateral triangle, therefore the ratio of their area, the small equilateral triangle to the large equilateral triangle will be L over 2 square divide L square, and that's going to be 1/4. Because there are 6 small equilateral triangles in the hexagon, therefore we use 1 over 4 multiply 6, and that equals 3 over 2. Therefore, the area of the hexagon will be 3 over 2 multiply 4 equals 6. The answer is C. Let's connect the 4 dots in each figure. Now the 4 dots will create a square, and the 2 squares are identical in both figures. And let's assume in the first one, the area between the circle and the square is the shaded area. And In the second one, the shaded area to be area between the square and the arcs. And these two shaded areas are also identical. Therefore, let's first calculate the shaded area in the first figure, and that's going to be pi r squared subtract let's connect the opposite side of the square, and we can see that this is r. Therefore, the side length of the square will be square root of 2 times r, and its area is its square, and that's going to be pi r squared subtract 2r squared. And this is the shaded area in figure 1. And then for the second figure, the white area in the center will be the area of the square, which is this, and subtract the shaded area, which is pi r squared subtract 2r squared. And simplify that, we get it's 4r squared subtract pi r squared. Now this area divided by the area of the original circle will be 4r squared subtract pi r squared divide pi r squared, and that equals 4 subtract pi over pi. Therefore, the answer is A. Problem 25. We can say that the area between the two squares are 4 triangles that are identical, and they are all triangles with a right angle, and the side lengths are A's and B's. Therefore, AB will equal to the area of two of these triangles, and 2AB will equal to the shaded area, which is 4 of the triangles, and it equals the area difference between the large and the small squares, which is 5 subtract 4 equals 1. Therefore, AB equals 1 over 2. The answer is C.